This is Bluepill STM32F103C8T6. It runs at 72 MHz clock speed. Use the Cortex M3. The previous board I use normally STM32F4 class. They run at high clock speed. This one has only 20 kilobyte of RAM and 64 kilobyte of flash. However, when my embedded DOS detects it has the 128 kilobyte of flash. I have ported the embedded DOS to this board so we can use this development board same as we use the other F4 class board, Bluepill. Previously, I have ported gerbl 1.1 to this board. It runs very well. I think it's time to port to the F4 as well, but since I port the embedded DOS, the first thing I will do is put gerbl on the embedded DOS and on this chip first, and then we can move on to the F4. This one use the micro USB. The Bluepill use micro USB. When you plug it in, it has use the USB as the serial port, and then we can format and then we can make a hello world, and now we have hello. So if only 48 bytes, it's a hello world. We also have a debug. Let's show the debug. Make debug, and now we have a file called debug. So if you debug, then it will display the content of the RAM, and we can say this is the starting of the directory. So if you look at the files, it shows here. This is where the content of the hello starts, the 48 bytes, then we hello world comes in, and then we have the debug come from here. So here we have the display SSD1306, and I use the same port of the SPI1 as well as the GPIO 3 pins for the CS, reset, and the DC pin. So let's make SSD1306. And then we can make the LCD demo. The code is identical on the LCD demo for calling the DOS to calling the DOS or driver to display on the LCD. The driver itself has slight difference because F4 and F3 on the GPIO setting is slightly different, but the majority code is the same. So if I make the LCD demo, it will start there. And now we can see we have the SSD1306, SSD1306, and driver installed. Now we can see LCD demo. So you can see porting embedded DOS to STM32F103 is quite easy. I will find other board and put the embedded DOS there.